So 5.3 is properties of logs. Again, we are going to continue with logs. In 5.4, we are doing more logs, so they don't go anywhere, okay? We just use them in different ways. The first thing we're going to talk about is called the change of base formula. So if you wanted to find the log of something in which the base is not e and the base is not 10, and you didn't have a calculator in which it allows you to change the base, then the change of base formula is what you use. And you do log either base 10, so log of the larger spot, so not larger as in value, but the thing that we say log base blank of, what follows the of goes in the top. And then the base, so the little subscript thing goes in the bottom. Think base, bottom, okay? And you can write it as, it will ask you as a ratio of common logs, which is log base 10, or a ratio of natural logs. And that's your ln. So if I had log base 3 of 23, I would rewrite it as log 23 over log 3, or log ln 23 over ln 3. And both of those will give you the same answer, which would be 2.85. So we're going to practice it. Take out your calculator. So again, you can choose either one. If it says log of 23, you literally hit the button that says log of 23. Make sure you close your parentheses, though, if they open them, which most of them do. Then, God bless you, divided by log, and it's going to open the parentheses. You don't have to close them after that, but you want to do that. And the same thing for ln. So ln of 23, close the parentheses, divided by ln of 3. And you get 2.854044983, or rounded to 2.85. If we reverse it, log base 23 of 3. Again, you can use either one. Common logs would be log of 3 over log of 23. Natural logs would be ln of 3 over ln of 23. And if you do either of those, you get 0.3503, so on and so forth. So it would round to 0.35. Some calculators actually allow you to change that base, and you would need to do that. However, questions sometimes will ask you to give the change of base in the ratio. So you've got to know how to enter that in. And if you didn't have a calculator, that's how it would ask you to leave it. So just rewrite it as a ratio of common logs, or rewrite it as a ratio of natural logs, and then you would leave it like that without the calculator. Yeah, but if you do ln in the top and the bottom, that ratio still works. So both those will give you the same answer. It doesn't matter if you do logs or you do natural logs. Yep. All right. So rewrite the ratio as a ratio of common logs or natural logs. You don't need both. You just need one or the other. And then evaluate and round to 4 decimal places. So which one goes in the top of number 1, the 4 or the 25? 25. So it can either be log 25 over log 4, or it could be ln 25 over ln 4. Doesn't matter which one. I sometimes pick log and sometimes pick ln. Doesn't matter. God bless you. 2. All right. Questions on that one? So log of 12 over log of 2, or ln of 12 over ln of 2, because it gave you the or. It doesn't matter. And then that 6 bumped up the 9, which bumped up the 4. Okay, now we're going to deal with 3 properties of logs, and we're going to use them in 2 directions. One way is to expand a log, and one way is to condense a log. All right, so the property of products means you're multiplying 2 things together. So when we have one single log, like you're only going to have the log written once, and you're finding the log of 2 or 3 things, anything that's being multiplied together, we expand this out by adding. So I would find the log. It looks almost like you're doing the distributive property, but it's very different. You're finding the log of the first term in that product, and you're adding it to the log of the second term of that product. That's how we expand. When we condense, we go back the other way. So if it starts as addition, when we condense, it becomes multiplication. And the rule is really based on the power of exponents. Have a great day, guys.
Thank you, too.
The rule about this comes from if you were to take your exponents, let's say, and we multiply two things that have an exponent, what do we do with those exponents? You add them. So when you multiply logs, you add them to expand, okay? That's where that comes from. Then the second one is the quotient property, which means division. If we start by dividing two terms, and these could be values or these could be variables or a combination of the two. When you're dividing them, when you expand, you subtract. And if you think about your rules of exponents, if I had x over 6 over x to the second, what do I do with those exponents? Subtract. So when we divide, we subtract, okay? And then the last one is the power property. When you raise a power to, or when you raise a base to a power, you actually bump that power to the front of the log and you multiply it. It becomes a product. Because when we raise a power to a power, what do we do with those exponents? Multiply, okay? So when you multiply, you add. When you divide, you subtract. And when you raise a power, you multiply. We're going to go both ways with this. We're going to take something that is only one log and expand it. And then we're going to take ones that have multiple logs and condense them.
But what if when we have a log, there's a negative exponent, then do we do the quotient property because it's a fraction now?
No. So, well, you can actually do both, right? So, remind me, I'll go back to that because I'll show you both. But you can do both. Yeah.
For the first one, in the parentheses, like the UV, would it be like 2 times 3 or would it be like 6 when you have to factor it?
Both.
Okay.
Yep. Yeah.
And when you're talking about the UV, are you saying you'll add the UV on the product?
You'll do log base A of whatever the first thing is, which in this case is U, plus log base A of whatever the second thing is.
Oh, when it's multiplied.
Correct.
I thought it was talking about like the U and V, but no.
No. It's being two things being, or three things. It could be multiple things in there being multiplied together. Okay. Let's look what I'm going to. Okay. So this one, notice, like look down this slide, right? All of them only have one log. So it's going to eventually say expand or condense, and you'd have to be able to know which direction you're going in. If there's one log, you're going to expand. If there's more than one log, you're going to condense, okay? All of these have one log, so we're expanding all of these. And then if we can simplify once we expand, we're gonna. So I want you to think about doing this two ways. We're going to do it the expansion way first, but you could also have done this with your mental math shortcuts later. So we're going to compare them. What is the exponent on the third root of 5? It's a third. So this would be log base 5 of 5 to the 1/3. Now that's an exponent. So this is the power product or the power property, which means I take that 1/3 and I bump it to the front. This would give me 1/3 times log base 5 of 5. What's log base 5 of 5? 1, and this is 1/3 times 1, which is 1/3. Sometimes you're going to get to keep going, and sometimes there's going to be variables there, and you'll just leave it expanded. Now, the shorter way to do that, unless it specifically said you have to expand, the shorter way to do that is to say, what would that be? What would I have to raise 5 to get to 5 and 1/3? And that's 1/3. So you can also have done it, and much shorter, to do it that way. But sometimes there's going to be variables involved that you can't do that way, so it will say expand, and you'll have to expand. So we're just going to keep practicing in both ways if we can. All right, go to 4. There's a couple of things going on here. This is 5 times x to the 3rd times y. So we're going to start with the multiplication. How do I separate out multiplication? Addition. So log base 4, don't forget the base, of 5, plus log base 4 of x to the 3rd, plus log base 4 of y. With me so far? So look at the first one. Is there anything I can raise 4 to get it to be 5? No. So it's literally going to stay as it is.
You'll break it down
No. You can, but you don't need to, because now instead of separating it out, this 3 is going to come to the front because of the power. So log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. So if you had separated out, you would combine it back together, because it would be like combining like terms. You want it in simplest form, which is that. And I would have checked every single one. There's obviously nothing I can do with the x or the y. We're just expanding. Yep, and there's nothing you can simplify there. Yep. All right, now go to 5. Now I've got a quotient, right? Which means what? Good. So ln of the square root of 3x minus 5 minus ln of 7. What's the exponent if it's a square root? So I'm going to rewrite that as ln 3x minus 5 to the 1/2 minus ln of 7. And then the 1/2 bumps to the front. There's no way to expand the sum there, and we can't separate out the 3x unless it was separate from that 5. So it literally stays just like that. Chris?
How'd you get the 1/2?
That exponent, so like anything that's a square root has an exponent of 1/2. If it was a cube root, it would be 1/3. If it's a fourth root, it's 1/4.
Okay.
And if I could simplify ln of 7, there's nothing I can raise e to, like, to get to 7, so it stays that way. Okay, now we go to 6. And you've got a couple things happening here. You have a product in the numerator, and you've got a root in the denominator, and you've got the minus because of the denominator, right? So it would be log base 3, and I can keep this together at first, like the 4x squared can stay together for now, minus log base 3 of the square root of y.
It's not supposed.
Now I have to break apart the 4 and the x. So it becomes log base 3 of 4 plus log base 3 of x squared minus log base 3, what's the exponent on the y? 1/2. Anything else I can do there?
Don't you move the decimal?
Move all the exponents to the front. So log base 3 of 4 plus 2 log base 3 of x minus 1/2 log base 3 of y. So you also want to train yourself to always check the ones that are of like numeric value. Like go back there and make sure there's nothing I can simplify that. So can I raise 3 to a power to get to 4? No. So I leave it as it is. But if it was like 3 and 3, that answers 1. If it was 3 and 9, that answers 2. You would keep going.
So if you get the x equals whatever, you just put that in for that equation.
Yep. You can simplify them separately.
How would you get your signs? Like, you start off-
Anything that's in, so like the product, like any, because these two are both being multiplied, those are going to be plus when I expand them. And then comes the minus because of the division bar. The rule is really, though, because there could be more than one term in the bottom, anything that's in the bottom is going to have a minus in front of it. And anything that's in the top is going to have a plus in front of it. Because sometimes you'll see these in different order. Like I could have done something positive, which we're going to get to because we're going to condense. But I could have done a positive, then a minus, then a positive. Both the positives are going to the top, and the negatives going to the bottom. I'll show you an example like that, though. Questions so far? Oh. All right, now we're going back the other way. And again, your instructions are going to say expand or condense, or expand and condense, or vice versa, like something generic like that sometimes. And you have to know that, like, by looking at these, there's more than one log. If there's more than one log, I'm going to condense it. If there's only one log, I'm going to expand it. So I'm going to look at 7. You can do this in, like, you can do this all in one step, or you could do this in multiple steps. So we're going to kind of go slow the first time. The first step I do is bump the powers back. So anything that's got an exponent on the front, bump to the exponent. Or anything that's got something on the front, I'm going to bump to be the exponent.
Are you reversing one?
Correct. So this would be log of x to the 1/2 plus log of x plus 1 to the 3rd power. That's first step. Push the powers back. Now if it's addition, it becomes what when I condense it? Multiplication. And an exponent of 1/2 is what? A square root. So the goal is to get it to be 1 log, which it is. No 1/2, no 1/3, no exponents that are fractional because you can convert those into radicals. And then it would be times x plus 1 to the 3rd. Camilla.
If it's like dividing, like if it's subtracting, you put it into a division. Which one goes to the top? Which one goes to
Whatever's got the minus in front of it goes on the bottom. So like look at 8. First thing we're going to do is bump the power.
You can't distribute that
Nope.
because of the exponent.
Oh, you can distribute it, but you don't need to. You mean this part?
Mm-hmm.
You'd have to expand and you'd have to multiply x plus 1 3 times and then distribute the square root of x. Don't put yourself through that torture. You don't need to. All right, so this would be ln of x plus 2 squared minus ln of x. And the minus does what? Division. So the ln goes in the front. X plus 2 squared is in the numerator. And the x goes in the bottom. You can put parentheses around it. You don't need it. If it's in the fraction, it's grouping it anyways. All right, look at 9. The whole thing has a 1/3 in front of it. So where's the 1/3 gonna go? It's gonna go to each of them. Like you could literally distribute it to each of them, or you could wait to the end and make it 1/3. So if I distribute it now, God bless you, I get 1/3 log base 2 of x, God bless you, plus 1/3 log base 2 of x plus 1. So because those brackets are there and the 1/3's on the front, it would go to both. Then I can bump the power back. So I'd get log base 2 of x to the 1/3 plus log base 2 of x plus 1 to the 1/3. And then it's addition, which means it would condense to be multiplication. And that 3rd root, or that 1/3 becomes a 3rd root. And because they are both underneath that 3rd root, I can combine this into 1. So it would be the 3rd root of x times x plus 1. So that's as condensed as it gets. They're both under the root because they both had the 1/3. Yep. You don't need to. Yep. So if I had done it the other way, and first condensed in here, I would have gotten log base 2 of x plus log base 2 of x plus 1 becomes log base 2 of x times x plus 1. And then the power comes back and it goes over the whole thing. So log base 2 of x times x plus 1 to the 1/3, which is log base 2 cube root of x times x plus 1. Whichever way makes the most sense for your brain, do it. Bella.
The other part when you're adding, when you're distributing it, can you just distribute it first, or
When you're adding,
like when you're distributing the 1/3? Can you distribute to each equation first?
yeah, that's what we did in the purple, right? Is that what you mean? This,
Yeah, but instead,
right?
no, like bring it to the back of it.
Oh, sure.
Okay.
Like instead of keeping it as 1/3, can you bring it to the back as the 1/3 in one step? Absolutely. Yeah.
Can we simplify the expression
You don't need to. You mean by distributing?
Yeah.
Yeah, you don't need to. You're not going to be able to get it any further. All right, so go to 10. So 2 options. 1, distribute that 2 to each one, which would really be raising it to the power of 2, or wait till the end. Totally up to you. If you distribute it, so I'll do them both. If I distribute it, I'd get 2 log x plus 3 minus 4 log x minus 2. Yep.
Can't you just put the 2 as an exponent?
Yep.
Since that's what it's going to become.
Yeah. But don't forget your 2 at the exponent. So you're going to have to move the second one. You have to do exponents twice. Does that make sense? Like if I move this 2 here, then I have to move this 2 here, which is fine. You still have to do it, but you just can't forget.
Okay.
So then I'd get log x plus 3 squared minus log x minus 2 to the 4th. And the minus means divide. X plus 3 squared over x minus 2 to the 4th. Camilla.
If it doesn't have a number next to the log, do we have to write 10, or can we just write?
If it doesn't have it, you keep it as log. You can write 10, but you don't need to. Yeah. If it has another number other than log or ln, then you have to put it. Yeah. No. No. So like if you had done it the other way, if I had first condensed what was inside here, I would have gotten log of x plus 3 over the 2 here would bump to the exponent. Good morning, x minus 2 squared. Okay, so I put first, I condense what's inside. I bumped this power to the back. That's where I'm at. But the 2 is still on the front, which means the 2 would have to go to the exponent here. And I'd get log of x plus 3 squared. And then x minus 2 squared raised to the squared power, or raised to the second power, would be x minus 2 to the 4th. So whichever way like makes the most sense in your brain, stick to it, because they're 2 different ways and they totally get the same answer. Questions? Okay, so I'm going to show you 2 things. One, I'm going to go back to Rodrigo's question, but I'm going to show you 2 things because this comes up every year. If it said log of x to the 3rd. No. 3 log of x minus 2 log of y plus 5 log of z. I hate z's, but we'll put it there anyways. Okay. This time the minus is only on that middle term. It's not like I put log of x to the 3rd over log y to the 2nd and then times z to the 5th. Those 2 totally go together in the numerator. So everything that has a positive, which are going to be these 2, are going to be in your numerator. So x to the 3rd and z to the 5th. And then anything that has a negative is going to go to the denominator, so the y to the 2nd. And think about that in reverse, okay? So it doesn't matter the order because you could move those all around, right? I could move addition and subtraction in any order as long as I keep that sign with the 2. So I could have bumped this to the end and it's the last thing you do. It doesn't matter when you do it, as long as whatever has the minus goes to the bottom. And then again, think about that in reverse. So if I had log of x to the 3rd over y to the 2nd, z to the 5th, when I expand, what's the sign on the z? Minus. What's the sign on the y? Minus, because they're both in the bottom. Anything in the bottom gets the negative in the top. It doesn't matter order, okay? So this would be log of x to the 3rd minus log y to the 2nd minus log z to the 5th. And then all the exponents would get bumped to the front.
Could they all be minus?
If it was 1 over, sure. Where am I at? Log y minus 5 log z. Yeah, so I don't know if you heard, well, Cole just asked, what if, could they all be minus? And if it was like log of 1 over y squared z to the 5th, I don't know what I just wrote there. Then it would, the first thing would actually be log 1, so it would start positive, and then the other ones would both be minus. And log 1 can get simplified because 10 to the 0 power gives you 1. So that's what I'm going to go to next is this question. There's now like 3 ways to solve this question. One, and probably easiest, mental math. What's the answer to that? -2. I need it to go to the bottom and I need it to get squared, right? That's the fastest. But I could also go back to like the old school. If this equals x, then 10 to the x equals 1 over 100. To get 100 to the top, it would be 10 to the x. Don't do this. This takes forever. And then x would equal -2. That's the first method we learned. Now think of it in terms of expanding. If it's a fraction, it would become what when I expand? Subtraction. So it'd be log base 10 of 1 minus log base 10 of 100. What's log base 10 of 1? 0. What's log base 10 of 10? What can I raise 10 to get to 100? 2. And then it's -2. So 3 completely different ways to do that same question. You got to stick with whatever you're best at. Valeska. This one? Yeah.